Hi y'all, I want to do a help for your project too. Now I'm going to use the uniform distribution. In your project, I tell you to use the normal distribution, but the basic steps are still the same. So the first thing we have to do is we're doing hypothesis testing and see how well hypothesis testing does. So we're going to first create 100 samples of size 30 from the uniform distribution. Now remember, when I have a sample size of 30 or more, I can assume that I'm in a sampling distribution of the sample mean for samples of size 30 that would be normally distributed at least approximately by evoking the central limit theorem. So I can, for these 100 different samples, perform hypothesis tests on them, even though the parent distribution's uniform. When we have large samples, remember the sampling distribution becomes approximately normally distributed. So let's take a look. I'm going to go in here and I'm going to calculate random data. And as I said, I'm going to take it from the from the uniform distribution. So I want to create samples of size 30, so the number of rows of data to generate is 30. And I'm going to store them, and since I want 100 of these, I'm going to store them in columns 1 through 100. So I'm going to type in C1 through C11. Now, our lower end point is 0, our upper end point is 1. If you remember the uniform distribution, we now know what the mean would be. We have a formula for the mean and the formula for the standard deviation. If you don't remember, please go look in your books for the uniform distribution, because we're going to need those values later on for the population standard deviation and the population mean. So I'm going to hit OK, and now I've created my samples. So I've got 100 different samples very quickly from Minitab. Now we're going to do a hypothesis test for all 100 samples. In other words, we're going to take the mean of each of those samples and do a hypothesis test on them. Now we know that this sample came from a distribution and it has a standard deviation, a population standard deviation of 0.287. So we're going to take each of these samples and do a hypothesis test to see if the mean is 0.5. So, like I said, we know sample size is 30. Sigma is 0.287, or approximately 0.287. So we need to state our null and alternative hypothesis. So we assume that the mean is 0.5. In fact, we know that it is. And the alternative is that the mean just doesn't equal 0.05. We're going to test that claim at a 0.05 significance level. In other words, we don't want to make an error more than 5% of the time. So this test should work at least 5%. It should work at least 95% of the time. Now we're going to let Minitab find our test statistic and to find our p-value. And this is how we do it. We go to Stat. We go to Basic Statistics. And we want to do a one sample z-test. In other words, Minitab, when it asks for standard deviation, they expect it to be the population standard deviation. So I left click on this and I say where my samples are. Well, my samples, I left clicked into here and I put my samples are in C1 through C100. So Minitab is going to perform this 100 times for each of the different columns. Now my data isn't summarized because it's in these columns. So I skip right down to population standard deviation, because this is a z-test. When they say standard deviation, as I stated before, they're expecting the population standard deviation. So I write that in there for the uniform distribution. I want to perform a hypothesis test, so I go to the box to the left of that and I left click, and I have to put in what my null hypothesis mean is. And the null hypothesis mean for the uniform distribution is 0.5. Now Minitab's default is a two-tailed test. How do I know that? Because if I go into options, this will let us know what alternative we want. And it's, as I said, Minitab's default is always not equal to. If we were doing a right-tailed test, we do the greater than. If we were doing a left-tailed test, we'd do the less than. But we're doing a two-tailed test. We just want to see if the mean, we're testing to see if the mean is 0.5. The alternative is we don't think it's 0.5. Don't worry about the confidence level. We're going to hit OK. So now we've got everything we need in there. We left click on OK. And now we have in our sessions window the result of 100 hypothesis tests. We've got the test statistic and the p-value that goes with it. And so what we're going to do is, in this particular project, is we want to see if we get p-values less than 0.05. How many times when we took a sample did we get a sample that was not significant? And think about it. We did come from a uniform distribution with a mean of 0.5, but when things are normally distributed, we can truly get a sample that's going to give us out into the tail end that we would reject. So our actual technique will have some error involved in it just by the properties of the normal distribution. So how do we count this easily so we don't have to go through each of these? Well, I can use Excel to help me do that. What I do is I'm going to copy all of these just like it is, and I'm going to open up Excel. And I'm going to paste all that information into Excel. But when I paste it, you're going to note that it's not in cells and separated. But I can mess with the data to make that happen. I left click on data up here. I go to putting text to columns. So I left click on that. And now it's going to do the fixed width. All I have to do, can you see what this will do for me? It's going to put everything in columns very nicely for me. So I left click, and I left click again, and then I hit finish. And now I have the p-values all in one column. And what I want to do is I want to go through here and find all the p-values that are less than 0.05. So I'm going to do that same formula that I showed you how to do for the other, for project 1. I'm going to say equal and do an if-then statement. If, and in here I'm going to say if this value is less than 0.05, nice, and now I've got that in there. Now we knew that p-value was less than 0.05. So let's go through here and see how many of the 100 have less than 0.05. That means from our sample, the probability based on our sample mean, we would make a type 1 error. So we have 1, and you can highlight it however you would like to do that. We have 1, 2. So we've, based on our sample, out of the 100, about 98% of them were fine, and the 2% said that the mean was not 0.5. So 2 out of the 100, our technique actually didn't work. So what you're going to find is each of you will get a different number, or not every single one of you, but you'll get different numbers for the number of times that you get a p-value less than 0.05, because each of you are getting 100 different samples because they're all random. So you might get 3, someone might get 4, someone might get 1. It all depends on how your samples go. So now I'd like to show you how to do a hypothesis test when you have summarized data. So a researcher thinks the mean number of geese that migrate during a 3-month period to a particular pond has decreased from 13. A sample of 40 days, a random sample of 40 days, the mean number of geese present was 12.6. The population standard deviation is known to be 1.3. Test the researcher's claim at a 0.05 significance level. So we know that our sample size is 40, that the population standard deviation is 1.3. From our sample, we got 12.6, our sample mean, that is. So when we do our hypothesis test, remember we have to state the null and alternative. So we believe that the mean is it was believed that the mean was 13, but the researcher thinks it's decreased, so the alternative is less than 13. State our significance level. Well, alpha is 0.05. And with Minitab, it will calculate our test statistic and our p-value. So that will take care of 3 and 4 of our hypothesis test. So we go in here and we go into stat, basic statistics. Once again, we're going to do a one sample Z since we know what sigma is. And it's no longer samples in a column. We've got summarized data, our sample size being 40. The sample mean of our 40 days was 12.6. Our standard deviation was known to be 1.3. And our hypothesized mean is 13. And I don't want to do a two-tailed test because we want to test the researcher's claim that that number is decreased. So we have to go into options, and we now have to change our alternative to the left-tailed test, or less than. We hit OK, hit OK again, and there we have our test statistic and our p-value. Since the p-value is less than 0.05, we reject the null hypothesis. Therefore, we would say at a 0.05 significance level, there does seem we have enough evidence to support the researcher's claim that the mean number of geese has decreased from 13. Now, if we have a t-test, it's very similar. We would just go into stat, basic statistics, and we do our one sample t-test. And that way we don't have to worry about tables or anything. So if we had that problem, but instead of it being the population standard deviation that we knew, and we had a sample size of 40 with that sample mean of 12.6, but this time let's say that our sample standard deviation we actually calculated from our sample, and it ended up being something like 1.27. We could still do this with the t-test. We perform our hypothesis where we're looking at the mean being 13, but we think it's decreased. So we make sure that it says less than, hit OK. And there we get our test statistic, which is the T0, because we're in the student T distribution, because we don't know what the population standard deviation would be. And we get our p-value. So that's using our Minitab to do a hypothesis test. And if we know what the standard deviation is, we go to one sample Z. If we didn't, we go to one sample T. Thanks for watching.